Given the graph on the left, we want to determine all the key characteristics of the function shown here on the right. We first want to determine the domain and range using interval notation. Recall the domain is a set of all possible inputs or x values. To determine the domain, we analyze the graph from left to right or along the x-axis. Notice the leftmost point on the graph is this point here where x equals -3, because it's a closed point, -3 is in the domain. And now moving to the right, there are no holes or breaks in the graph, and therefore the domain includes all of these x values moving to the right until we reach the rightmost point, which is also a closed point where x equals 8, and therefore 8 is also in the domain. The domain is the closed interval from -3 to 8. Closed interval indicates the endpoints are included, and therefore we use square brackets using interval notation. The range is a set of all possible outputs or y values. To determine the range, we analyze the graph vertically or along the y-axis. Notice the lowest points on the graph are these 2 points here where y equals -5. This indicates -5 is in the range. And then moving up, the function takes on all the y values or function values all the way up to the highest point on the graph at this closed point here where y equals +4. The range is the closed interval from -5 to +4. Next, we want to determine the number of y-intercepts. A y-intercept is a point where the graph intersects the y or vertical axis. Notice we only have one y-intercept, this point here, the point 0, -5, and therefore we enter 1. Next, we want to determine the number of x-intercepts. An x-intercept is a point where the graph intersects or touches the x or horizontal axis. There are 1, 2, 3, 4 x-intercepts. Next, we want to determine the number of zeros. The zeros of a function are the x values for which the output or function value is 0. Graphically, the zeros are the x values of the x-intercepts. Because we have 4 x-intercepts, we have 4 zeros. For the next 4 questions, we want to determine whether the function is increasing, decreasing, or constant over the given open interval. The first open interval is from -3 to -2. Over this open interval, notice from left to right, the graph is going downhill, and therefore over this interval, the function is decreasing. As x increases, f of x or y decreases. Over the open interval from -3 to -2, the function is decreasing. The next open interval is from -2 to 0. Here's the open interval along the x-axis, the open interval from -2 to 0, and therefore we're analyzing this piece of the graph, which notice over this interval, the graph is going downhill from left to right, and therefore the function is also decreasing over this open interval. The next open interval is from 0 to 1, which is this open interval, which means we need to analyze this piece of the graph here. Notice over this open interval, the graph is going uphill from left to right. The function is increasing over this open interval. The last open interval is from 1 to 3, which is this open interval here, which corresponds to this piece of the graph, which from left to right is going uphill, indicating the function is increasing over this interval. Next, we want to determine the minimum value of the function. We determine the minimum value of the function by determining the lowest point on the graph of the function. Notice this function has 2 points that are the lowest points, this point here and this point here. Notice the ordered pair for the point on the left is 0, -5. The point on the right is 6, -5. The minimum value is the y value or function value of -5, which occurs at 2 locations, at x equals 0 and x equals 6. But again, the minimum value is the y value or function value of -5. To determine the maximum value, we locate the highest point on the graph, which we can see would be this closed endpoint here, where the ordered pair is -3, 4. And again, the y value or function value of 4 is the maximum value that occurs at x equals -3. The maximum value is +4. I hope you found this helpful.